show you how to solve simultaneous equations. Simultaneous equations is just using two equations to find two unknowns, for example, x and y. And today I'm going to show you a method called elimination, where we add or subtract the equations together to find either x or y. So in this first example, I'm going to add the two equations together, and you'll see why in a moment. When I add the x terms together, so 6x plus 4x is 10x, and 5y plus negative 5y is 0. We add them because we want either the x's or the y values to cancel. So in this example, when we add, the two y terms cancel each other out. So I'm going to keep adding. 62 plus 8 is 70. Because now I've got an equation just in x that I can solve to find the value of x. So this means 10 multiplied by something gives me 70. So that means the something, the x value, must be 7. So I've already found the value of x. Now, to find the value of y, you have to write out one of the original equations again. It doesn't matter which one because they'll both give you the same answer. So I'm going to just choose this one at the top here. So write that out again. So 6x plus 5y equals 62. Now I'm going to change the x value to 7 because x is 7. So instead of doing 6 times x, we've now got 6 times 7. So you can either write brackets here or you can write multiply because they both mean times. And everything else in the equation stays the same. So I'm going to keep solving. I need to find the value of y. So 6 multiplied by 7 is 42. Remember, everything else stays the same there. And now I need to rearrange this equation to get y by itself. So I need to move this number 42 to the other side. Remember, when things move across the equal sign, they change sign. So this used to be positive 42, but when it moves over to the right-hand side, it becomes negative 42. So I'm going to carry on writing this solution up here. So I'm left with 5y on the left-hand side. Then I've got the equal sign, followed by 62 minus 42, because the sign of that number changes. So 62 minus 42 is 20. So now I've got 5y equals 20. So you can probably see what the value of y is already, because 5 multiplied by y gives me 20. So y must be 4. Okay, on to the next example. So if we try and add these two equations together in example number 2, nothing cancels. Look, 4x plus 1x is 5x. 2y plus 2y is 4y. So by adding the equations together, we can't eliminate either x or y. So this time, I'm going to subtract the equations. So let's see what happens when we subtract. 4x take away 1x is 3x. And 2y take away 2y, well, that's 0. So this time, the 2y's cancel because we're subtracting. Now, don't forget to subtract everything. So 50 minus 20 is 30. Okay, so the value of x must be 10 because 3 multiplied by 10 gives me 30. So I found the x value straight away there. Now for y, remember you need to write out one of the equations again. It doesn't matter which one. I'm going to choose the bottom one this time just because it looks a bit easier. They're smaller values. So I'm going to choose that one. But like I said before, it doesn't matter if you choose the other one, it will give you exactly the same answer. So write that out first. So x plus 2y equals 20. Now you need to substitute in your value of x. So x is 10. So you're going to replace the letter x with the number 10. And now we have an equation that's just in y, so we can solve that equation to find y. So we need to move everything away from y until y is by itself. So we're going to move that number over to the other side. Remember, when that positive 10 moves across the equal sign, it changes sign. So that becomes negative 10. So now the equation is positive 2y on the left. Then we've got our equal sign. The 20 hasn't moved, but this becomes negative 10. So I'm just going to tidy that up a bit. 20 take away 10 is 10. So the value of y must be 5. because 2 multiplied by 5 gives me 10. Okay, let's make them a bit harder. Okay, so in example number 3, the bottom equation, it looks a little bit different to the ones we've seen so far. So far, in all of the other equations, we've had x and y terms on the left-hand side of the equals, with the number here by itself on the right-hand side. Whereas this equation here has everything on the left-hand side of the equation, so it looks a little bit different. Just to make it look a little bit easier, I'm going to move that 8 to the other side of the equation so that it's in the same layout as the equation above. So remember, when that 8 moves to the other side, it changes sign, so it becomes negative. So this equation turns into 2x minus 4y equals negative 8. Now that I've rearranged this one, I'm just going to cross that out. I don't need that equation anymore. And now, when I'm looking at this one at the top and the new one I've written here, it's like the previous 2 examples. I've got x and y on the left-hand side of the equals and the numbers on the right. So now I need to think about whether I'm going to add the equations together or subtract them. Remember, you want to try and eliminate either the x values or the y values. So if I add them, well, 2x plus 2x is 4x, 3 plus minus 4y is minus 1y. So by adding, nothing cancels. So in this one, I'm going to be subtracting, which makes sense because 2x take away 2x is 0. Remember, you want either the x's or the y's to go to 0. So let's subtract everything else. So the y terms are 3y take away negative 4y. So be careful because you've got a minus here. So 3y take away negative 4y is the same as 3y plus 4y, which is 7y. And when I subtract the numbers, it's the same thing. We've got a double minus. 13 take away negative 8 is the same as 13 plus 8, which is 21. So the value of y must be 3, because 7 multiplied by 3 gives me 21. So there's the y value. Now, using exactly the same method as before to find the other letter, write out one of the original equations again. So I'm just going to choose the top one. It doesn't matter which one though. So 2x plus 3y equals 13. Now I need to substitute in my y value. So I'm going to replace the letter y with the number 3, because y is 3. So let's do that up here. So I'm going to write this out again, this equation, except when I get to the y, I'm going to change this to 3. So I'm going to put my brackets in, although if you prefer, you can write times, it's the same thing. And now, tidy it up a little bit. 3 times 3 is 9. So 2x plus 9 equals 13. And we're just solving this equation until we found x. So remember, you need to move everything that's not x to the other side of the equation. So we're solving. So let's move this 9 to the other side. So this changes to a negative when it moves to the other side. So we've got 2x equals 13 minus the 9, which leaves me with 2x equals 4. So the x value must be 2, because 2 multiplied by 2 gives me 4. So x equals 2. Okay, so just like before, I want to try and decide whether I'm adding or subtracting the 2 equations together to eliminate either the x's or the y's. So if I add the equations together, 8x plus 3x gives me 11x, so the x's don't cancel. And minus 2y plus minus 2y is minus 4y, so they don't cancel either. If I subtract, well, 8x minus 3x is 5x, and minus 2y minus 2y, well, that turns into minus 2y plus 2y, because the 2 minuses turn into plus, which gives me 0. So we're actually subtracting the 2 equations. So whenever you see the same sign here with the same number, you're subtracting. So let's subtract everything else. So remember I said 8x minus 3x is 5x. Minus 2i minus minus 2y goes to 0. And minus 2 minus minus 7 is the same as minus 2 plus 7, which is 5. So the value of x must be 1, because 5 multiplied by 1 gives me 5. So just like before, write out one of the equations again, substitute in your value of x, and then solve to find y. So if I take the top equation, I've got 8, but I'm replacing the x with 1. Everything else in that equation stays the same. Well, 8 times 1 is just 8. So I'm going to solve this equation to find y. So I'm going to move my value of 8 to the other side of the equation, so that becomes a negative 8. I'm going to write this one up here. I'm left with negative 2y on the left-hand side of the equation, so I need to write that down. Then I've got my equal sign. This hasn't moved, and remember, this becomes negative 8. So let's tidy this up. On the right-hand side, minus 2 take away another 8 gives me minus 10. So, minus 2 multiplied by y gives me minus 10, which means y must be 5. Because minus 2 times 5 gives me minus 10. So, one more example, and then that's it for today. In this last one, it's just like the previous example in that we're subtracting the two equations, because minus y minus minus y is the same as minus y plus y, which is 0. But something extra I want to point out in this question. Normally, when we do subtracting, we subtract the top one and then we minus the one underneath from the top equation. So you're always doing the top minus the bottom. Well, when we're solving simultaneous equations and we're using this elimination method, we're allowed to bend the rules a little bit, and if we want to, we're allowed to subtract the other way around. So you're actually allowed to do this bottom equation minus the top one, and it will give you exactly the same answer for x and y at the end. So in this one, I think I would prefer to do this one minus the top one, just because this 7x number is bigger than 4x. So I'll avoid getting a negative value with the x here. So if I did 4x minus 7x, it would give me minus 3x. But if I do it the other way around, it gives me positive 3x. So it really doesn't matter which way around you do it. It's just I know some people dislike negative numbers, and you might want to try and avoid that if you can. So let's do the subtraction. So I'm doing 7x, take away 4x, which is 3x. And remember, we're doing the bottom minus the top, so you have to do the same thing for the numbers. You're not suddenly allowed to start doing it the other way around and do the top one minus the bottom one. We have to be consistent and do the same thing throughout. So, minus 18 minus minus 9 is the same as minus 18 plus 9, which is minus 9. So the value of x must be negative 3, because 3 multiplied by negative 3 gives me negative 9. So there's x. Then, just like before, write out one of the equations again. I'm going to choose the top one, simply because it looks a little bit easier, because these are smaller numbers. But remember, it doesn't matter which one you choose. And then I need to replace the x value with negative 3. So I write this out again, but when I get to the x value, I put my brackets and my negative 3 value. And then I'm solving the equation. So 4 multiplied by negative 3 gives me negative 12. Everything else remains the same for the moment. And then I need to move everything around until y is by itself. So if I move that negative 12 to the right-hand side of the equation, it's going to change sign, so it will become positive. I'm left on the left-hand side with negative y. Then I've got the equal sign. This didn't move, so this is still the same. And this changes to plus 12. Don't forget to write down that negative sign. Some people, when they do this, a careless error is just to forget the negative, but you need to keep that in the equation. So, negative y equals, well, minus 9 plus 12 gives me 3. So this isn't finished, because we have to find the value of y, and it currently says negative y. So if I change the sign of this one to positive y, it means I have to change the sign of this one as well. So the answer is y equals minus 3. So I hope you feel a bit more confident now with solving simultaneous equations. In another video, I will show you a different method for solving simultaneous equations, which is substitution.